Hi everyone, I'm Josh Fincannon.
And I'm Deonis Marina. We're students in construction engineering and technology at Oklahoma State University.
Today we'll be walking you through our final soils project for SEAT 3432 site development. We focus on the earthwork, geotechnical conditions, and stormwater management plans for a project site located at West Midwest Boulevard and University Avenue in Guthrie, Oklahoma.
This report ties everything together: soil testing, compaction methods, groundwater analysis, and how proper planning protects the environment during construction.
We started with the earthwork section. Specifications 02201 covered everything from structural soil standards to how materials had to be tested and handled.
Our project references ASTM testing methods like D422 for soil particle size, D1556 for in-place density using the sand cone method, and D698 for moisture density relations.
Contractors had strict guidelines. Unsuitable materials like peat, topsoil, or debris had to be identified and removed. Areas with soft, unstable soil had to be over-excavated and replaced with engineered fill.
Compaction was critical. The fill had to reach at least 95% maximum dry density. Sand cone testing, nuclear density testing, and even rubber balloon method were acceptable ways to verify compaction.
The geotechnical study focused on Highway 169 exit ramps C and D in Tulsa County. It showed that most of the soil was soft to stiff silts and lean clays, overlaying weathered limestone.
To analyze the soil properties, engineers conducted 6 prize cone tests, 3 dilatometers tests, and the 3 standard penetration tests. These help measure the soil strength, stiffness, and drainage characteristics.
The allowable bearing capacity of the site was determined to be 2,000 pounds per square foot, with long-term settlement estimated to be less than half an inch.
Special recommendations included removing these top 12 inches of soil, scarifying and compacting the subgrade, and using geogrid reinforcement with Type A aggregate base for embankment fills.
Additionally, engineers advised installing edge drains and low permeability soil layer to prevent water infiltration that could destabilize the embankments.
Stormwater management was another huge component. Our project had to protect nearby country club lake from runoff pollution.
We delivered a site-specific SWIFT plan that included best management practices like silt fence, clean construction entrances, and inlet protection systems.
Construction activities were phased carefully, beginning with clearing and grubbing, the rough grading, stormwater system installation, utility work, paving, and finally stabilizing with grass seeding and mulching.
Costs for BPMPs were also included, like $2.50 per foot for silt fence and $250 per storm inlet for protection. Planning upfront reduces costly water pollution problems later.
This project showed us that soil analysis and storm planning aren't just check the box tasks. They actually control the success or failure of construction projects.
Without detailed soil knowledge and drainage control, structures settle unevenly, roads crack, and erosion damages the environment.
By following ASTM standards, geotechnical recommendations, and BMP practices, we can ensure strong and safe and sustainable construction.
Thank you for listening to our presentation.